Hello.
Hi.
Is it better? I hope you can see now.
Yes, please.
Okay. In fact, you have to see. You have to see.
It has become blur again.
Oh, me, it will be fine, okay?
Okay.
The network is like that. Sometimes it's disturbing, but yeah, I can't do anything about it. So I have to take it as it is. Okay, so you realize that cos 180 minus theta is equal to negative cos theta. What it means is that what cos 180 minus theta can do, cos negative theta can do the same thing. All right. I hope you are following.
Yes, please.
Good. So in place of cos 180 minus theta, we are going to substitute cos minus cos theta because they are the same thing. All right. If they are the same thing, then look at it. Open your eyes. The rest are still not here. I do. Look at what we have. We have R is equal to F1 squared plus F2 squared minus 2F1 F2. But times cos 180 minus theta. And we just realized that cos 180 minus theta is the same as negative cos theta. Is that okay? So in place of cos 180 minus theta, we are putting this minus cos theta. If you substitute this is what you have. R squared is equal to F1 plus F2. Now, negative times negative is equal to what?
Positive.
Plus 2F1 F2 cos theta. Are we okay?
Yes, please.
So that's the reason why what cos 180 minus theta can do, only cos theta will do it. So if I give you an angle of 30 degrees, the angle that will be opposite to the resultant will be 150. Okay, the 150 is the cos 180 minus theta. But cos 180 minus theta is the same as negative cos theta. So that is the same as plus 2F1 F2 cos theta, cos 30. So if I give you 30, the angle opposite to the resultant will be 150. But what cos 150 will do, cos 30 can do the same thing. Are we fine?
Is it yeah?
Hello?
Please, is it possible you could go over again?
It is not possible. All right.
Please.
Now let me go over because of the network. Everybody, are you there?
Yes, please.
Linda is still not here. Linda. Okay. I do. All right, let me go over. Regina, I hope you are following.
Yes, please.
Okay. Okay, so we have established that the resultant R will be equal to R squared will be equal to F1 squared plus F2 squared minus 2F1 F2 cos of 180 minus theta. Then we pick cos 180 minus theta and expand. And in the expansion of this, we saw that the expansion of cos 180 minus theta will be cos 180 times cos theta. This is minus, so plus sine 180 times sine theta. This, then we put in our values. What is cos 180? Cos 180 is equal to -1. Cos theta, so this is times cos theta plus sine 180 is 0 times sine theta. So in effect, we realize that cos of 180 minus theta is equal to negative of cos theta. Abafala, are you okay?
Yes, please.
Good. Meaning that what cos 180 will do, negative cos theta will do the same thing. So in place of cos 180 minus theta, we are going to put negative cos theta. So in the resultant value, we put F1 squared plus F2 squared minus 2F1 F2. Then cos 180 is equal to this. So times minus cos theta. F1 squared plus F2 squared. This is negative times negative, so plus 2F1 F2 cos theta. So it is either you use, in determining the resultant force, you use cos 180 minus theta or cos theta. But when you are using theta, this will change to plus. When you are using 180 minus theta, it will be minus. Example, if you are giving the angle between the forces to be 30 degrees, okay, then R will be equal to F1 squared plus F2 squared minus 2F1 F2 cos of 180 minus 30, or R squared will be equal to F1 squared plus F2 squared plus 2F1 F2 cos of 30 degrees. Are we okay?
Yes. Yes.
All right. So that is how the two angles relate. The two angles relate. Now let's consider when the angle between the forces is obtuse. Here we look at acute. Okay, so theta lies between 0 and 90. Let's look at theta line between 90 and 180. All right. I'm cleaning the board. If you are writing this, please quickly do so I can clean, okay?
Okay.
Oh, and in a share, oh, we are better, they don't come here, we didn't Arabia,
Yes, we said yeah.
why is Nana Yemqua?
No, right. I can get to her if you want. I didn't realize she wasn't here.
Ah, okay. So here 90 degrees is less or equal to theta, less or equal to 180 degrees. So theta is greater than.
That side of the board.
You can see it.
Yes. Yes, please.
It's better now. So the angle is greater than 90, less than 180. Meaning the angle theta is obtuse, right?
We said yeah.
Hello.
Is it possible we could lower the camera a bit? I was almost done copying the latter part.
Okay, hurry up.
Thank you. Thank you, Mr. Yeah.
Are you true?
Yes, please.
I want to force natural light to permeate the classroom and to illuminate it well for me. Okay, so Regina, are you there?
Yes, please.
I'm marking Regina Bruce. Okay, so if we want to determine the resultant, we resolve this into a parallelogram. And a parallelogram is a four-sided figure with both sides equal and parallel and opposite interior angles to equal. So an equal version of F1 placed on F2, just as we were doing.
Mr. Yeah.
Hello.
Now we can't see the part of the board where you are writing.
You will see, don't worry.
Thank you.
Okay, so the direction F1, then we create F2 and place it on F1. So when we do that, this is also F2. Whichever way we look at it, this plus this, it will be equal to when you have drawn a line from here to here. This plus is the same thing. So This will be the direction of the resultant. And the resultant, the direction will go up because this plus this, they are all coming to this destination, no matter where you look at it. Okay, so that's why the resultant R would have to go up. Now we will need this angle, either this angle or this angle. If I extend this line small, the angle between this and this is the same as this angle. So if this is theta, this will also be theta. So that this angle will be equal to 180 minus theta. Are we fine? Are you okay?
Yes, please. Yes, please.
Okay. Let me call one of you. She joined, but I don't know. She has gone off. And she's not coming, which is a worry. All right, so we are going to use cosine rule to determine R, just as we've done before. Hello, Linda. Good morning. Linda by a call. I'm okay on the there be also, as I maybe get a call, but I have wasted the environment. Yeah, okay, sorry. I'm coming, man. Okay. I'll join in, but I'll call. But see, okay. Okay. And you want the way free here, right? All right, so using the cosine rule, R squared will be equal to the same thing, F1 squared plus F2 squared. Please here, you can either use this side or this side for the same thing. Okay. The usual rule minus 2 F1 F2 times the cosine of the angle opposite to it. 180 minus theta. Okay. But because cos 180 minus theta is equal to negative cos theta, this R can also be equal to F1 squared plus F2 squared plus 2F1 F2 cos of theta. Are we fine?
Yes, please.
Now look at something. Here, theta is obtuse. So when you subtract obtuse from 180, you get an acute angle. Okay, you get, when you subtract 180 from obtuse angle from 180, you get an obtuse acute angle. So this will be any angle less than any angle. 180 minus theta will be any angle. Will be any angle less than 90. because already theta given to you is obtuse. Okay, so if you take cosine of an acute angle, it's positive. Cosine of an acute angle is positive. So what this will be maintained. Now, if you use theta, instead of subtracting it from 180, if you use the other counterpart, which is obtuse, cosine of any obtuse angle is negative. So when you point this, it will give you a negative value. So negative times positive will be negative, which will be the same as this one. So this is how it balances. All right. And the point is that no matter how you look at it, you need to get the same answer. No matter how you look at it, you need to get the same answer. Is that okay?
Yes, please.
We'll be solving questions, so you don't worry. Let me even give you one example. Okay. Are you done writing this? Are you done copying?
Yes, please.
Hey, the list another for. The list another for. Thank you for all get you. This is maybe 10 Newton. F2 is equal to 14. Now the angle between them is 120. We have to find the resultant. Of course, when you resolve it, the resultant will be in this direction. Just as we've done. So F2 R squared will be equal to.
Please, will you do another class in the evening?
Pardon?
Please, will you do another class in the evening?
Where do you want to go?
She's attending a practical class.
Oh, okay. And who is here? Who is talking?
The father, the dad.
Yeah, I just want to know the student's name.
Yeah, Mirabel.
Okay. Hey, Mirabella. Okay. You go and come out. I'll see what to do. Okay.
Thank you very much.
Mirabel, pressure. All right. Okay. All right.
Bye.
So R squared, which is equal to F1 squared plus F2 squared minus 2F1 F2 cos of. We will always require the angle opposite to the resultant. So 180 minus theta, which is 120. Please, I hope you are with me.
Yes, please.
F1 is 10. So 10 squared plus F2, 14 squared minus 2 times 10 times 14 times cos of 60 degrees. 100 plus, what is 14 squared? Hurry up, what is 14 squared?
196.
96.
196 minus 2 times 10 times 14, cos 60 is half. So you have 296 minus 140. Therefore, R will be equal to subtract 140 from 296. 6, 5, 1. Okay. R therefore is equal to the square root of 156, which is what is the square root of 156?
12.49.
Newton. This is the resultant. Now, since cos 180 minus 120 is equal to negative cos 120 cos 180, don't forget, and I'm quoting this from cos 180 minus theta is equal to negative cos theta. The relationship, the equation we proved. We can also determine R using this angle. Then R squared will be equal to 10 squared plus 14 squared. Okay. Minus 2 times 10 times 14. Now cos of 120. Sorry. So plus, okay, let me take my time so that those of you join late will follow. When you substitute, you have minus 2 times 10 times 14 times cos of negative times negative cos of 120. Please, I hope you're okay. Hundred plus 196 plus 2 times 10 times 14. Now what is cos 120? Please, this is plus because of negative times negative. All right. What is cos 120? Is equal to negative half. Right?
Yes, please.
So you have 296 minus negative times positive minus this. So we have minus 140. And what we have is this side. So in effect, we'll get the same answer for R to be 12.49 Newton. Are we fine? So both the acute and then the obtuse, or both ways, must give you the same results. Now, yesterday I was talking about this formula, R squared or I was talking about this being a super formula. Why? This formula applies to any angle, whether they are moving in the same direction, opposite direction, perpendicular, or acute or obtuse. And so the cosine rule is a super formula which applies to all situations of two forces or vectors. Let's see why. When two forces are moving in the same direction, what is the angle between them? When two forces are moving in the same direction, what is the angle between them?
0 degrees.
So this is equal to 0. When moving in the same direction. Go. So put 0 degrees for theta. You have cos. So you have F1 plus F2 plus 2F1 F2. What is cos 0 degrees? What is cos 0 degrees?
1.
Good. All right, so this is 1. So in effect, you have R squared giving you F1 squared plus F2 squared plus 2F1 F2. Now, let's look at something. When you have, now why are you there?
Yes, please.
You are quiet. Why are you late? For today. When you have F1 plus F2 all squared, I want you to expand this for me. Expand F1 plus F2 all squared. F1 plus F2 all squared. What have you had?
F1 squared plus 2F1 times F2 plus F2 squared.
Come again. F1 squared.
F1 squared plus 2F1 times F2 plus F2 squared.
All right. So you realize that the expansion of this is equal to what we have here, isn't it? All right. The expansion of F1 plus F2 squared is equal to when we have put 0 into the cosine rule. And so we can therefore say that, oh, okay, then this side, if this side is equal to R squared, then we can equate R squared to F1 plus F2 all squared. Now, when we take the square root of both sides, we have R being equal to F1 plus F2. The same equation as we earlier had. Please, are you okay?
Yes, please.
Okay. Akofola, do you have any question?
Yes, please.
What's the question?
I think I lost the explanation on why we were squaring F1 plus F2.
Okay. So when we put in 0, we got that the resultant square of the resultant is this. Okay. So if the square of the resultant if r squared is equal to f1 plus f2 squared plus 2f1 f2. Then if you have f1, the square of f1 and f2, if you square 1 plus f2 or the all squared, the expansion of this is equal to f1 plus 2 f1 f2 plus f2 squared. Are you okay?
Yes, please. But the first one, we've left out the cos of the angle.
No, we said because they are moving in the same direction, theta will be equal to 0. So when you substitute 0 here, you have cos 0.
Which is 1.
Cos, yes, which is 1.
Okay.
So that's how come we got this. That r squared is equal to this. So if you expand f1 plus f2 and you have this, then you can say that, oh, okay, then I can substitute f1 plus f2 all squared for this, which will be the same. Are you okay? So
Yes, please.
r squared will be equal to f1 plus f2 all squared. So that when you take the square root of both sides of the equation, and clearly you do this to get r, you have r to be equal to f1 plus f2, which confirms the same thing we learned when we consider the resultant of two forces moving in the same direction. Are you okay?
Yes, please.
Good. Let's consider when two forces are moving oppositely. And Regina, when two forces are moving oppositely, what is the angle between them?
Please, it's 180 degrees.
Good, good. So here theta is equal to 180 degrees. Let's put 180 degrees either for this one. Please don't forget this formula is the same as when you are using the 180 minus theta. So both formula will work. So we have r squared is equal to f1 squared plus f2 squared plus 2f1 f2 cos 180 degrees. Theta is 180. So cos 180. If you use this one, you have cos 0. You got 180 minus 180. All right. Now, what is cos 180 degrees? Cos 180.
-1.
So minus 2 f1 f2. Because this is -1. If this is -1, then if I have f1